this be an introduction to the aliveness of the Deerfield basalt. We have a kind of rind of cooled lava. We know it was cooled, frozen quickly in place because its gas bubbles are preserved. And here's a split which shows that the gas bubbles are mostly full of these little mineral packets. It's a lava pillow, and so is this. This is two lava pillows conjoined, and I'm not making that up. It's the poets in charge of geologic description. The poets in charge of this descriptive science. Geologic reason itself seems to have been really taken over by the poets. This is a little lava tube or a little nestled pillow, and this is a larger pillow that's nestled into the pillows below. The top of the pillow has this semicircular, this large dome shape. And the pillows stack on top of each other. This is another top of the pillow, and they have concentric fractures, which you can see that fracturing there. This is already cooled, this stuff, and there's beautiful language written by the great poet Michael Alibi in the Oxford Companion for the Oxford Dictionary of Earth Sciences that it pays to turn to when we are contemplating the beauty of the lava pillow. I mean, look at this bulbous lava pillow. And you see again the rind, some of the fracturing as that rind continued to bend and be pushed. Pillowaceous material. This is the outside of a lava pillow. Pillow lava. Here's another one. It was evidently mined out of, I think probably out of the quarry in North Deerfield. And this is a particularly beautiful rind. I believe that's what they call it. Pillow lava, folks. Pillow lava. Here's another one. A rind. And this demonstrates the poetic morphology of this basalt, which is a fine-grained, dark, fine-grained igneous volcanic rock. Basalt is a mafic volcanic rock, which is to say consists of magnesium and ferric elements conjoined, and igneous, that is to say volcanic rocks, come in two flavors, chocolate and vanilla, mafic and felsic. Felsic meaning feldspar and silica are major components. This is a felsic rock. Felsic granite. Granite is felsic, very felsic, igneous rock. These are all felsic. This is mafic. But how does mafic rock, well, what is mafic rock? Mafic rock is deep mantle material. Iron and magnesium are major components under the crust. not of the crust itself necessarily, that they need to be deposited, and they're present in this rock in quantity. I don't know, maybe they're not, you can't harvest it or whatever like you can from banded iron formation, but that's another story. Anyway, this is a mostly felsic rock with some mafic minerals. There they are. I mean, I think that's what you say. But yeah, felsic has quartz and feldspar, two of the most common minerals of crust. Mafic rock makes up the ocean floor. It also comes up onto the crust, as for example, this mafic rock here, which came up onto the crust 201 million years ago. It's been dated. I think these little crystals can be dated, maybe, or something in it can be dated. I don't actually think it is these crystals. It's something in the, anyway, it has been dated, and there it stands in all its strange glory. Who could have anticipated that these pillows would represent, the poetry of motion of this mafic lava, this magnesium and iron-rich lava that bubbles up and cools underwater. And you know that because the outer surface of this lava is frozen into a nice cool rind that sort of morphs and bends as the pillow elongates, and then the end breaks again, and another squirt of lava comes and another pillow happens, and they stack up. And very often you find pillow lavas many meters in thickness, as they are at the bottom of the Deerfield Formation in certain areas especially, but other areas too. I think there's pillows on the top of it, indicating that the lava was solidifying in lakes, seemingly, in certain cases. So there you go. Deerfield basalt and its pillow lavas. And just to drive home the point with the promised poetry of the great Michael Alibi here, we're talking about piles of elongate basaltic lava pods, having the general appearance of a stacked accumulation of pillows, often many hundreds of meters in thickness. That's the definition of the phenomenon we're talking about. And as Michael Alibi elaborates, each pillow is surrounded by a chilled, fine-grained lava skin and sags into the pillows below it. The pillows are rarely more than 1 meter in diameter, and in the cross-section, each one has a convex upper surface, as we saw earlier, radial and concentric fractures. We were looking at the radial ones, and commonly a central cavity or tube which once fed lava to the front of the advancing finger. The finger is the solidifying plume of underwater lava. The morphology indicates that the pillows continue to behave as fluid bodies after the chilled carapace had formed. You hear the roar of the Connecticut River in the background, and see there, that's the Deerfield basalt. That's a ridge of it. And that's it in the wild, as it were. We've been looking at the quarried parts, but that ridge shows it being exposed by the river, bits and pieces of it falling down. As it cools, it cracks, and those cracks form these chunks that then get torn off, but it's a very resistant surface, so the river piles up against it. And there it is. And this is the last thing we'll look at. An amazing chunk of Deerfield basalt, again, just thrown in here, probably quarried. But look at this wavy banded structure. I think this was a kind of puzzle for a long time, but I think what it is the top of a Pahoehoe lava flow. And this is introducing more terminology, but we just can't stop because the reality of the Deerfield basalt does not stop. And we are responsible to it, however briefly and terminologically, poetically. But this is a Pahoehoe structure, I think. Maybe on the top of a pillow. It's got these large vesicles that clearly show a drift, a movement in the solidifying mafic basalt. But there's this wavy structure, and it looks forever. And you see here it's been broken. Here it's crested like little ripples, like ripple marks. But how can it's not ripple marks? Because it's not a sedimentary rock. It's a igneous rock. It's a basalt. It's a volcanic rock, and you see the shatter there. And these white stripes, that's from the very surface of the basalt. You see that white stripe right on the very outer surface. So this is a little area that's been preserved. This has been shaved, flattened, and what remains is this Pahoehoe pattern. That's a real word, a Hawaiian word, a beautiful Hawaiian word for lava that cools slowly on top, but still, as it's still flowing, and forms this undulating, billowy, pillowy surface full of these draping folds and draping wrinkles and ropey, and it's a ropey surface, like as in a rope. And Pahoehoe, I think, means ropey or smooth or something, or both. I don't know. But that's a Pahoehoe structure, I think. And I keep saying that word. I looked up the pronunciation, so we're getting it straight from the horse's mouth of the internet there. So, yeah, the Deerfield basalt is not to be underestimated.
And above all, not to be underestimated are the Pahoehoe lava flows that mark the top of the Deerfield basalt, and are beautifully articulated by the poets at Encyclopedia Britannica, who write that Pahoehoe lava flows are characterized by smooth, gently undulating, or broadly hummocky surfaces. The liquid lava flowing beneath a thin, still plastic crust drags and wrinkles it into tapestry-like folds and rolls resembling twisted rope. Pahoehoe lava flows are fed almost wholly internally by streams of liquid lava flowing beneath a solidified or partially solidified surface. Typically, the margin of a Pahoehoe flow advances by protruding one small toe or lobe after another.
We're here on today of all days, just astounded, not necessarily as never before, but definitely once again, at the incredible aliveness of the Deerfield basalt, which you see in its glory here, and it's really, this is an important strip of it, suffice it to say. Why? Because it's the very top of the flow of this lava, beautifully just displayed here by erosion. I mean, you see the unruly, bulbous nature. That's a
Pahoehoe undulation.
That's what the poets in charge of geologic reason call a
Pahoehoe undulation.
Here's a little bulb poking out, pushing up, and you know, and here's another big swell of lava, The whole thing is cracked. We will discuss the cracks. This might look like a surface that's been trashed by erosion. Actually, it's just been lovingly pried open and revealed. And this flaw here is not imposed upon this rock by erosion, but this is part of the nature of the rock itself. This is a beautiful fold in the flowing, viscously flowing basalt, which, as you can see, is permeated or populated by swarms and swarms of bubbles, little vesicles, gas bubbles rising through the flow. This is a little pocket of sandstone nestled in amongst the
Pahoehoe undulation
of the basalt, and you can see the cracking due to tectonic stresses, and you can see the vesicles that are so distinctive of the upper part of the flow. Here's the continuation of this little area. Once upon a time, sandstone would have nestled. This sandstone would have filled this crack as well, and then more and more sandstone would have built up and up. I hadn't even noticed the beauties of this specific zone, but suffice it to say, we have some things to discuss, some things to observe. That's the sandstone. We're calling that the Lower Mount Toby Formation, and this is a little more of it scooped and scoured out, you see, by the glaciers coming this way, but I'm pretty sure that's glaciated. I don't know what else could make it like that, beautiful like that. This surface is probably glaciated, but not too much, it just opened up. And here we find the layers of sandstone proclaiming themselves. They're laying in on top of this basalt. The paleo-horizontal it's important to understand. Paleo-horizontal is like this. So to put ourselves into the world of this basalt is to accept the horizontal that it provides, and just observe the pornographic eloquence of this sunlight upon this rock. And by pornographic, I just mean beautiful and wonderful, Just want to display these glorious pillows, also from this zone we're investigating, namely the top of the flow. Plenty of features that I just don't quite know how to interpret. For example, this kind of splashing look. Maybe it has to do with flowing, but this is mudstone. I think little mudstone particles, perhaps, or iron, I don't know, splashed into the vesicular basalt, the top of the flow, and sort of, this would be pure mudstone nestled into the area between the pillows. Here's a nice, smooth, pillowing surface. A crevice of sandstone folded into and more of this scattering, this spattering, this really formidable gesture that these pillows, the pillowaceous tops of the lava is making. It's a sight to behold. It's a sight to behold, no mistake. And here's more. You can just see that surface, maybe it's just the way the bubbles were distributed, the vesicles were stretched in the final moments of cooling, Then the vesicles were filled with this sandstone, and then this splattering, alive, flowing look to these vesicles, if I can call it that. This is interesting, just chunky bits of lava, I think, sort of cooled on top. I think this is, these pillows, I think means flowing underwater. Here's a basalt area. Here's the contact. Here's a chunk of basalt that's sort of, I don't think it's a chunk of sandstone sitting on top of the basalt. I think the basalt is just right underneath the top of this, but nonetheless, interesting. These sliced pillows here. I mean, there's a glorious one with that rind popping out, and just the basalt is flowing along, and this is the cooling edge, and these are the vesicles that never got filled with sandstone. But these vesicles are filled with sandstone. See, the water trickled through and filled those vesicles. And here's the empty vesicles. Well, I think they must have had some minerals in them probably, but dissolved out. And then here's the sandstone filled vesicles. So again, here's that glorious top of the flow world. And it's just so, look at that texturing. It's quite something. So we go back to where we started and return to our question, looking at this crazy, I mean, you see how it sort of, it looks like it's moving. I don't know. It looks like it's moving, being stretched. I guess I can't really convince myself that it's moving one way or another. I love how these pillows have been jointed like in this really regular way by the tectonic stresses, the faulting, but it's not what we're focusing on so much, just the aliveness of the basalt. And I mean, this is where you gotta come to find it. That's really the best way to look at it from further out, although so our interpretation of that is not a Jackson Pollock-esque splatter of mud onto the top of the basalt. That's the deformation of the vesicles stretched out as the basalt cools. Those vesicles get filled with sandstone, and then that's what it looks like.